Next, we have a dear friend of mine and a wonderful Australian, Professor Veena Sahajwalla. She's an internationally recognised material scientist, engineer and an inventor who's going to be presenting on how materials research, innovation and infrastructure can solve the problems of the future, build a circular economy and achieve net zero. So please give Veena a very, very warm welcome as she comes onto the stage.
Thank you very much, Tim, for that very warm welcome. Really, it's an honor and a privilege to be here this morning. I guess it's exciting to listen to all the things that Alan's just been telling us, which is a perfect way, I guess, for all of us to reflect on a couple of the key points. If I may pick up on the messages, I really like the point that we're talking about here, that when we make products using recycled materials, it's not so much whether we can recycle a material or not, it's much more about whether the quality of that finished product actually meets the requirements for the job that that product is meant to do. So if you're talking about products like you heard Alan talk about, noise walls, well, I mean, you know, as he said, it's got to be durable, strong, it's got to do the job. So I guess the question in all these conversations that we're having when we talk about use of recycled materials and, of course, putting them into products, it comes down to, of course, quality of feedstock, but it also comes down to, are we manufacturing appropriately? Are we simply assuming that the standard business as usual ways of making products is going to be good enough? And of course, are we then expecting magically that the products that are coming out at the other end are going to be fit for purpose? And are we sort of just assuming that, you know, when some plastics are considered, as we heard this morning, as nearly 500,000 tons of material in the plastics domain that is available for us to put into good reuse and divert them away from landfill? But then, of course, we have to recognize there are many different kinds of plastics that are available to us. You've all seen the various codes and the specifications and so on. So do we just assume that, let me pick up on one example of the category 7 polymer. And that category 7 polymer, of course, typically will contain, you know, products that one might say are hard plastics, difficult to recycle. But of course, the reason why I was saying they're hard and they're difficult to recycle is because they're not necessarily recyclable in a traditional way. What if you could actually redesign and rethink how manufacturing could be done by taking exactly those ones that were considered too hard to recycle? And what if you could make completely different products from that? And that's exactly what we're trying to do. So the Smart Center at UNSW, and I wanted to start by, I'm really glad it's a nice opportunity, thanks to the conference organizers, to do a bit of show and tell, right? Because of course, these are real practical examples of what we're producing in our microfactories. So this is an example of a plastic filament that we've made using exactly those kinds of plastics that were considered hard to recycle. Or, oh, no, but that's really the ones that can't be produced in a traditional way. Or can you actually achieve quality out of that? Well, of course, these are the important questions we should all be asking. You know, even if you made this plastic filament from 100% plastics, and if you said, right, okay, I now need to make the finished product, is my finished product also going to meet the specifications and quality? So it should always be about quality of that finished product, and is it fit for purpose in terms of a given application that we're trying to achieve? So again, the real test with all of these feedstock materials, if you convert feedstock into resources and then into a finished product, the real test lies whether the end user, whoever's using that finished product, is actually going to say that this meets the specs and the quality requirements for a given product. So it was, of course, the challenge that we had to face when we were running and setting up our own microfactories. For us, it was very much about, yep, we've made plastic filaments. Now what? Are there building and construction projects going on where, of course, we could trial and test real applications? And so it was pretty much like, you know, the fairy sort of godfather or godmother that turned up one day in our microfactory saying, you know what, actually, I'm after these specific clamps. I need 1,000 of those. My entire project is actually going to come to a bit of a standstill if we don't get this up and running. Do you guys mind testing it out? Well, guess what? This is what we produced. 3D printed clamps that are, of course, being used. Long story short, the realities are that you can take plastic filaments or any plastic feedstock, convert them through innovative solutions and pathways. And of course, the reason why we have to acknowledge that not all plastics are the same, just like you would talk about different kinds of metals, right? We just assume that metals, of course, are all recyclable, and so we've heard about steel and aluminum and all of that, and we go, right, okay, we can make different kinds of metal alloys by using recycled metals. So it's the same sort of hard questions we're posing. We are at that cusp of challenging ourselves when it comes to sustainability of materials, all kinds of materials, whether they are plastics, glass, rubber, and all the materials we've heard this morning, about how do you actually convert them into product. And this is where, of course, the journey of green materials for us comes to life, because we're showing multiple pathways. So going from sort of plastics that are one-dimensional, that long form, to, of course, flat, thin, flexible, to, of course, all the way into rigid structures. The question is, can it be done? Of course it can. The question is, what kind of manufacturing process would you use to bring that to life? And this is where, of course, the challenge comes to us in terms of how would you actually take all kinds of waste resources. So we've heard about, of course, glass as well this morning. Well, we've got all kinds of fabulous properties in waste glass. So why don't we look at that as an alternative to ceramics? And of course, that's exactly what we've done. High quality green ceramics being produced by using waste glass. And guess what? This has got waste textiles in it. So one might say the other important polymeric material, because we know that a large part of textiles is nothing but synthetic materials, right? So they're plastics in nature. Yes, there are synthetics and there are natural fibers, but the realities are that if you zoom right down at the fundamental micro level and molecular level, you'll actually find that in all of these cases, these material properties can still be harnessed over and over again. So that's really what we're saying. Instead of just seeing it as a macro product that needs to come back to life in the exact same form, what we're saying is, what if we could zoom right down at that molecular level and bring these products back to life over and over again? And that's exactly what we're doing at the Smart Center. We're really looking at how we might be able to take different kinds of waste, and now we should be calling it resources, as we've heard this morning. How do we actually take those resources, put them back into our supply chains? And this is what we're talking about. Circularity and circular economy comes to life when it becomes part of mainstream. It's not just, I think, Alan, you mentioned, not just an afterthought, but it is actually part and parcel of our thinking. It's part of how we develop solutions. So imagine if all these recycled materials and reused materials could indeed become part of our mainstream thinking. And of course, that's really what we have to do, is where we bring together all the fantastic research that's happening all across Australia. And yes, indeed, we do lead the world in many, many cases, to be able to show that there are different ways in which we can use different kinds of feedstock materials, and not necessarily think about it as converting like for like, but indeed reforming it, putting it into green manufacturing pathways, enhancing sustainability, and creating high-performance products. So that's, I guess, a journey. So one might say, well, okay, what about e-waste? Let me throw in another challenge amongst all the other challenges. Because, of course, one could argue, well, e-waste is one of those classic examples where you've got high-quality metals, you've got, of course, polymers, you've got glass reinforcement in those polymers, you've got all kinds of plastics that are there in different products and all the hardware, right? So why did I use this example? This one actually comes from all of that hard plastic that's there in our electronic systems, all of those printers and so on, right? All these plastics that are difficult to recycle, all of these kinds of circuit boards, that one might say, well, okay, how do we harvest that? We, of course, know that they are rich sources of metals like copper and tin. But how do we make it so that we can do it at the right volume, at the right scale, and most importantly, as we were talking about, right quality? What if we needed for electrification a certain metal alloy, and what if we needed a particular type of tin alloy that we could control? And this is the nice thing about these kinds of solutions. You can actually control the properties of these kinds of materials, and this is exactly what these kinds of technologies are all about. So our thermal micronizing technology shows that we can indeed produce high quality tin and copper, and the list goes on, but we can do that at temperatures that may well be lower than what a traditional smelter requires. So you might say, well, a traditional smelter for copper might need much higher temperatures. Therefore, how do we actually achieve decarbonization? How do we reduce the energy intensity? Well, this is where, of course, we can start to challenge the notion that everything must be always made in a traditional setting. We can actually start to challenge the notion that these kinds of micro-recycling techniques that we're developing can actually go back and harvest every element, every metal, every oxide that is present, whether it comes in the form of our e-waste or glass or plastics or indeed waste textiles. So here's an example of all of those batteries that you kind of may not think about much and go, well, what can we do with those, right? It's complex. But yeah, it is complex, but the fact is that all those important elements that are available to us in those powders can be harvested, and partnerships that we develop with organizations like TES are about saying it's not enough to just say we're collecting these batteries and we're doing all the hard yarn at the front end. What if we could actually set up micro factories that could harvest these zinc and manganese, and of course we know in lithium-ion batteries we've got metals like cobalt. So we've got a long shopping list of materials that we actually need. So if we do need that for any infrastructure, whether we expect them to provide mechanical properties, electronic properties, and the list goes on, well, we know we've got them right at the tip of our fingers. So the plastic filaments, and one might say, well, does it make economic sense? Yeah, it's all well and good to talk about recycling, reuse, it's all well and good to talk about these microfactories, but what about the economics, the underpinning economics? To show you an example in this case, which is why these kinds of micro-manufacturing solutions make sense, is because we're harvesting high-quality, high-performance materials, and we're expecting that from these materials. For these to be used for 3D printing, they have to be high quality. So that waste plastic may not be worth a lot. Those plastic filaments are worth a whole lot more. So if you're looking at, 20, 30, depending on the nature of filaments, to more dollars a kilogram, you've suddenly added value and you've created that value, but also importantly, you've enabled more and more local production. And that local production and regional production is exactly what we're doing. We're setting up some of our micro factories with our SME partners in New South Wales in regional communities and creating those place-based solutions where we can take that hub and spokes way of thinking and saying, what if that hub located in a region was specializing in producing these plastic filaments? Well, we wouldn't have to import plastic filaments then, would we? We've got enough feedstock material. We could then create a hub where these plastic filaments are produced. We could then have a whole range of manufacturers, and anybody who wants these on demand for their 3D printers could access. And of course, this is how innovation happens, because it's not just about saying, well, let me just make the same old over and over again, but actually allowing us to innovate, to basically incorporate a whole range of properties in these kinds of plastic filaments as an example. But then, of course, the list goes on. Once you innovate, once you see the opportunity, you can actually start to produce different kinds of products in-house. And that's exactly what we're doing, putting those plastic filaments in for 3D printing. They are, of course, our ability to harvest not just, of course, plastics from e-waste, as we were talking before, and all kinds of other plastic materials that come from the so-called non-recyclables or difficult to recycle plastics. Indeed, if we were to put them into our supply chains, we could actually create those multiple pathways so we can harvest whether it is indeed our plastics or all those important metals that we were talking about. But don't forget, there's also high quality glass. in our electronic systems, in our automotive waste. So again, it's a complex array and a smorgasbord of different kinds of materials. So this is an example of a microfactory at UNSW that we got started a few years ago. You can see, of course, on the right-hand side there, we are our local microfactory, trialing, testing, lots of old servers and hard drives and so on. And you might say, well, really, what do you need hard drives for? Well, actually, if you stop and think for a moment, you've got all kinds of important products, those magnets that are there in these kinds of electronic systems that are rich in rare earths. So if you actually start to zoom down in each of these different products, you might say, well, okay, for electrification, we also need these kinds of rare earth materials. Where are they going to come from? Right here, right now, in our own backyards, from different kinds of e-waste sources, and in this case, our hard drives that we're taking from our local e-waste providers. Okay, so we've talked about metals and plastics and so on. Here's a picture of what we've done with our green ceramics. Our green ceramics are, as I was showing you earlier, all these kinds of products made with waste textiles and waste glass. Of course, one might sort of have to start and ask, well, how did these two dissimilar materials come together? Well, this is where the science of micro-recycling comes in, where you can actually understand how fundamentally you create a brand new holistic product that allows you right down at the micro level to bring together some unique features and properties. And this is where, of course, we need to have strength. We need to have the kinds of properties in these green ceramics that are fit for purpose. So in this case, our green ceramic products are indeed, as you can see in these pictures, not only used in, as you see in those kitchen splashbacks and island bench faces, we've also put them into floor tiles. So of course, if you put them into floor tiles, you're expecting the right properties for those applications. You're expecting that they're going to have the right anti-slip properties. You're going to expect that these kinds of products that go into various building applications do meet building codes, and therefore they have the right fire-resistant properties. And so the list goes on, and this is exactly what we're saying, that just because they came from waste resources doesn't mean that the quality of those input materials is poor. Let's not assume that. In fact, the irony in a lot of these materials is that they are high-quality feedstock. We've made it once, and we've actually refined it to get to that point where it does a great job. So those electronic materials, like what we're talking about, metals, they've actually been refined from ores that were then harvested to produce high-quality metal alloys. And of course, if you've made high-quality metal alloys, guess what? Your e-waste, those printed circuit boards, are actually a rich source, much richer than what a copper ore could ever provide in terms of concentration of metals like copper and tin. So guess what? You've got about 10 times more metal concentration, 10 to 20% concentration in those circuit boards compared to what you have in ores of metals like copper. Why would you call it a waste? Just doesn't make sense, right? We're basically taking all kinds of valuable micromaterials that are embedded in this complex array of different kinds of materials. Whether you look at your automotive waste, and you might say, well, of course, automotive waste is great. We take all that steel, we recycle, absolutely we do. But what about all the other materials, those non-ferrous materials, whether they are in the form of plastics or glass, or indeed we're talking about rubber as well? Why don't we go after all of those? And that's exactly why controlling supply chains, managing it in a way, we know when we mine materials out of the ground, we have to control. If you're giving your mine material to your supply, to your supply partner, you've got to meet their specifications. You can't just dig something out of the ground and on-sell it, right? So much in the same way, as part of the supply chain, if you are controlling that and you're creating that economy, it automatically creates value. People are starting to see that as a valuable resource, but what that then means is suppliers and people who are bringing those materials in as part of this ecosystem have to, of course, know the quality of input material and have to manage it. So what we are talking about is both ends, knowing what the finished product should look like, and of course, that is dictated by its application. But we also know that when we've put in plastics, into making cars or electronic devices, they were really high quality materials. I mean, you don't put headlamp covers on a car out of some inferior plastic, right? They are high quality polymers that go into making, for example, those headlamp covers. So these are all examples of why don't we ask for each of these different kinds of products. Just because it's broken or damaged in an accident and you've damaged some plastic components in your car doesn't mean that that polymer can't actually be used over and over again for remanufacturing. And this is the point we're making, that every product, even if it has become obsolete or damaged at the macro level, at the micro level, at the molecular level, we're actually saying that it still has got life in it, not just for one use. What if we challenge the notion that we could remanufacture over and over again, right? So when we talk about circular economy and keeping materials out of landfills, we need to be able to understand how do we actually take the right scale and the right quality, and this is where, of course, scalability. So when we talk about microfactories, it's actually modular in nature. And this is what we're doing with our industry partners, adding modules as we go, depending upon the need and the growth that is happening and the products, the finished products that we are making. All of these different kinds of products require different modules and different controls in your system to manage and give you that finished product. So, okay, what does that ecosystem look like? In our case, this is exactly what we're doing. We're bringing together a whole range of suppliers and creating that kind of hub and spokes model that we're talking about. We're also bringing together as part of this system, which is, of course, laterally integrated, right? So what we might say is, what has indeed waste coffee got to do with the production of steel, for instance, right? I mean, I know you guys love your coffee here in Melbourne. So you might have a ton or two or hundreds of residual waste coffee left behind. Well, what we have shown is that coffee, indeed, all that waste residue could be rich in carbon and hydrogen that could then be used in the production of metals as an alternative, as a sustainable alternative to coal and coke that goes into making green steel. So these are the kinds of things we're talking about, the ability to use crumb rubber, the ability to use waste coffee and all of those materials and say, well, actually, if we were to decarbonize in the future, waste materials have got all those valuable elements and molecules, and in these cases, rich in carbon and indeed hydrogen molecules that can be liberated to produce green steel and many other metals. So these are the kinds of ways in which we need to think about what the future of materials is going to look like, what the future of products is going to look like. We're going to start to ask this question, are they made of sustainable materials and products? So the obvious question is, first and foremost, did we use coal and coke in the production of those materials, right? And if we have an alternative to provide a win-win outcome for both, of course, the waste resource, but also the finished product. So what if we could start to produce different kinds of green ceramics and green metals and so on out of these kinds of waste resources? And indeed, that ability to laterally connect, as you're seeing in this diagram, we've shown, of course, in this case, another example. What does a mattress recycler have in common with our green ceramic product? Remember where I was talking about waste textiles. So yes, there's a lot of steel that can go for recycling, but all of that mattress flock, that waste textile that's left over after we've shredded our old mattresses, that has gone into the production of these kinds of green ceramic tiles. And the reason why I want to take this opportunity to show, and you might sort of say, well, it's all well and good, it's prototype, fantastic. Are they used in any real projects? Real world projects, because remember, that was the real test of what we're doing. So these are the kinds of products that we've put recently, earlier this year in Sydney Olympic Park, pool applications for walling. And the reason why I make this point is, yep, absolutely. The time has come for all of these reused materials, recycled materials, to be seen as mainstream if they were to pass the real end user test. And that's the real test that we have to do. We have to do all of those engineering performance tests, absolutely. But when it comes to high quality products, and when it comes to products that are high value, we need to start to see how waste resources can actually be front and center of minds. That means they've got to appeal to our head, of course. They've got to meet the engineering specifications, but they also have to be aesthetically pleasing. Why would we put them in various applications in our homes, in our various spaces that we use if they didn't look good? So part of all of this conversation around different kinds of waste materials is about finding those multiple pathways. So everything we talk about when it comes to circular solutions through collaboration and through innovation must actually involve all of us working together. So if we are to build those kinds of regional economies, and examples of where we've started to do that already, our very first microfactory that was started out was actually in a small regional town. I'll mention the name of the town. I don't know how many of you have heard of Cootamundra. Any hands, any show of hands? Anyone heard of it? Oh, there is more than one. Thank you. Well, I guess for most of the time when we start telling people, we started this last year in Cootamundra, well, the usual question is, why Cootamundra? Why did you want to set up a microfactory there? And the answer was obvious. Our industry partner, who was collecting all of those waste mattresses and rubber tires, was simply someone who was collecting it. But now, within a short span of a year and a bit, he's actually gone and become a manufacturer. So you can imagine that transition where we can look at circularity as becoming part of that interconnected system. And that's really where that hub and spokes way of thinking is. Not everyone has to be a manufacturer, but it means that everyone can be part and parcel of that supply chain. So all of us who are owners of waste materials, we can put those wastes and design new products. So our green ceramics that we've been showing and talking about, all of these kinds of green ceramic materials that we can then design, put them back into end user applications is what this kind of collaboration and innovation is all about. So for us, I guess it's really a humbling experience when you know that a small microfactory that has produced products like green ceramics from waste resources can now take those kinds of green ceramic products and put them into world-class infrastructure applications. So to be able to achieve world-class, we have to have the end-to-end systems way of thinking. We need all kinds of materials to come into our ecosystem and to do the job that they're meant to do. So this is what we're doing. Indeed, some of our textile recycling partners, the two people you see in the middle there, Ben and Maureen, we met them, TRA, Textile Recyclers Australia, providing us with waste textiles right here in Melbourne a few years ago, just before COVID. The point is now they're part of that supply chain. They are our providers of waste textiles. We've got Andrew, our industry partner, who's basically processing some of those waste mattresses and got rubber tires. But we also now have got access, of course, when you're asking for people to give you waste glass and waste plastics, they turn up from everywhere. No shortage of materials. We're now producing all kinds of green ceramics, and you can see this beautiful table, this little coffee table that we're holding in our hands. This was manufactured from one large form of a green ceramic tile, which allowed us to show that all of these green ceramic tiles are not just about putting them into walling and flooring applications, although of course that's where bulk of applications for these products comes in. But all of those bespoke products where designers love the idea that you can make them out of, my favorite, the pink color tiles. You can do that by incorporating all of those waste textiles that would have otherwise gone to landfill. So the whole point about collaboration is that we are all part of this bigger system that allows us to say, as basically people who generate waste, which is where, of course, our local councils, local governments have a role to play in terms of providing that service, but we shouldn't be seeing this as a material where we just give up hope and we go, well, it's all too hard. Well, it's not. If you actually recognize that fundamentally all of these materials can be recycled, reused, and remanufactured over and over again. So it is actually showing that we can deliver impact. We can decarbonize, we can access all kinds of important materials, whether they are from our glass waste or indeed our electronic waste. All of this through real examples of what we've shown in setting up these interesting pathways to applications. And of course, not just applications in a few projects, but taking them out into various infrastructure projects and to apply them to show that it actually meets real-world expectations from end users. That is important. It's creating new opportunities and showing whether it's those plastic filaments that I was talking about right at the very beginning, whether these plastic filaments are fit for purpose. Can we actually make them from 100% waste? Can we put them into 3D printing? Can we manufacture all kinds of complex products for infrastructure applications? And absolutely we can, because this is where, of course, what we are saying is we're enabling a whole ripple effect in our economy. This ripple effect in our economy means that we're creating local jobs. We're actually making recycling and reuse part of our mainstream. And that's really the important message here. So ultimately, just before I wrap up, to show you a few more pictures of what our microfactories actually look like. Remember, I mentioned about Cootamundra. These kinds of microfactories, like I said before, are using waste glass, waste textiles. I don't need to tell you, we've heard plenty of stories of how plastics, of course, are pollutants and they are contributing a lot of harm to our environment. We do need to manage that better. And these are the kinds of examples that I was telling you about earlier that we have in manufacturing with our SME partner. In various cases, of course, they have gone into apartments. So you can see, of course, those pictures. So like I said, our microfactory out at Cootamundra, the top right-hand corner is the microfactory that we have, our pilot at UNSW. The bottom picture is really some of those modules that we have set up, and we grow those modules as we speak in our regional towns and communities, bringing that hub and spokes idea to life each and every day. So these are the kinds of panels that I've talked about with waste glass and waste textiles. And ultimately, of course, what we are talking about is these kinds of microfactories that allow us to show that we can multiply them over and over again, and that's what we're doing, whether it's about producing our plastics, our glass products, and ultimately aligning and bringing circular economy into action, where we bring together recycling and manufacturing to show that there are multiple pathways to success. And these kinds of world-leading research and technologies are being developed right here in Australia. We need to show that we can take advantage of our own science, and we need to show that these will deliver environmental, economic, and social outcomes for our communities. And ultimately, of course, all these real-world applications that I've been telling you about are happening as we speak. What we all have to collectively make that commitment, as we've heard this morning from Alan, is around being a part of that journey and asking for those kinds of recycled materials and recycled products as the first choice, not an afterthought. And that's really when we're going to shift the dial, when we all come together and support locally made products, creating those local jobs from recycled content and producing high-performance materials and products. So what are we doing in terms of shifting the dial, in terms of supply chains? Conventionally, we take these materials, we use it once, we put it into landfill. But in a circular sense, yes, it's a complex system, but if it was easy, we would have all done it. So the complexity here is to be able to recognize that there are many, many lives of many different materials that can be brought back to life over and over again. But this is exactly where we all work together and connect together to build new green economies off the back of green manufacturing solutions. So ultimately, I'd like to leave you with a final message and a final thought that this is all about collaboration and all of us working together. And of course, if we do that, we can certainly achieve a whole new future where we inspire each other with our stories. It's a win-win outcome for our planet and for our people. Thank you very much. Thank you.
Thank you so much, Veena, for that truly inspirational keynote address. Now, I know there's been a number of questions for Veena that have been asked. We don't have time to deal with them on stage at the moment, but I'd encourage you, if you submitted a question, to search Veena out over the various breaks we have during the day and ask her directly.